Hello everyone, our group is here to present the topic of the balanced transportation problem.
We'll explain this using example of an electronics manufacturing company in India, which has different production locations and distribution centers. Through this example, we'll show how the company can plan its shipments smartly to minimize transportation costs. Let's get started.
Let's explore how a leading electronics manufacturing company plans the distribution of its products from its 3 factories to its 3 distribution centers across India, all while aiming to minimize transportation costs.
The company has 3 production facilities: Factory X, producing 300 units, Factory Y, producing 400 units, and Factory Z, producing 200 units each week. These electronic devices are distributed to 3 regional centers. Center P requires 350 units, Center Q needs 250 units, and Center R demands 300 units weekly.
Since the total supply equals total demand, both 900 units, this forms a balanced transportation problem. The challenge now is finding the most cost-effective allocation. First, the company applies the northwest corner rule. This approach starts from the top left corner of the cost table, filling demand and supply until both are satisfied. Following this method, the company assigns shipments step by step until all demands are met. The total transportation cost 113,000 INR, a simple method, but not the most efficient.
Now let's break down how the total transportation cost is calculated for each method. The formula is simple. Allocated units multiplied by cost per unit.
Starting with the northwest corner rule, the company allocated 300 units from Factory X to Center P at 15 per unit. So the cost for this route is 300 times 15. That equals 4,500.
Next, 50 units are sent from Factory Y to Center P at 8 each, which totals 400. From Factory Y to Center Q, 250 units are sent at 14 each, making 3,500. 100 units go from Factory Y to Center Y at 11 per unit, totaling 1,100. Finally, 200 units move from Factory Z to Center R at 9 each, which is 1,800. When we add up all these costs, the total transportation expense for the northwest corner rule is 11,300.
Next, the company uses the least cost method. This strategy always picks the cheapest available route for the next shipment. By allocating the lowest cost routes first, the total transportation cost drops significantly to 8,250 INR. Now let's calculate the cost for the least cost method. Here, the cheapest available routes were chosen first. 350 units were sent from Factory Y to Center P at 8 per unit, giving us 2,800. 200 units from Factory Z to Center R at 9 each, that's 1,800. 250 units from Factory XX to Center Kis at 10 per unit, 2,500. 50 units from Factory Y to Center Y at 11 each, 550. And finally, 50 units from Factory X to Center R at 12 each, 600. Summing these up, the total transportation cost using the least cost method is 8,250, a much better outcome than the northwest corner rule.
Finally, the company uses the more strategic Vogel's approximation method. This method calculates penalties, the difference between the 2 cheapest costs in a row or column, to prioritize decisions and avoid expensive allocations later. Using VAM, the total transportation cost also comes out to 8,250 INR, the same as the least cost method, but VAM often gives a more balanced distribution for future optimization. Finally, using Vogel's approximation method or VAM, the allocations were slightly different, but the cost turned out to be the same. 350 units from Factory Y to Center P at 8 equals 2,800. 200 units from Factory Z to Center R at 9 equals 1,800. 250 units from factory X to center Q at 10 gives 2,500. 50 units from factory X to center R at 12 adds 600. And 50 units from factory Y to center R at 11 totals 550. Once again, the total cost using VAM is 8,250.
So the takeaway is simple. Choosing the right allocation strategy has a big impact on cost. Both the least cost method and Vogel's approximation method reduce transportation expenses by over 3,000 compared to the northwest corner rule, making them smarter starting solutions for further optimization.
Forever young in this display.